Alright, where should we even start? We should start with the clock first. So we can see this is our clock. This is the pause, and you can see just how laggy this is. The moment I release my mouse, the cursor changes, but it takes a while to initialize whether the connection is correct. You see, it takes a while, and if I just draw a connection, it takes a while for it to establish that connection. So it's very frustrating. Alright, so this is P, this is from the pause button. The reason that I connected it with a flip-flop is that a flip-flop can store digits. What a pause button do is that when you press the button, it toggles the flip-flop. Otherwise, if you don't use the flip-flop, you have to keep pressing the button for this input to be high, right? So you see, you press the button and the flip-flop toggles. So currently it's play, pause, like this. This is the clock. This is the AND gate controlling the input. This is the clock in fast. And the clock in fast is the faster version of the clock in. We actually put that to the user input, which is the circular shift registers here. The clock in fast is controlling the keyboard and these registers, so that the keyboard is working at a higher frequency than the asteroids falling, so that let's say specifically in this case we put it across 3 flip-flops. Supposedly the frequency halves with each flip-flop, right? So by the third flip-flop, clock in fast is 8 times the frequency of clock in. So when the asteroids move 1 row, your spaceship can move a maximum of 8 columns. Upon 1 operation by the asteroids, your spaceship can do 8 operations if your finger is fast enough, to be a more technical and formal term. Alright, that's the clock. And this clock in is used at a lot of places. Let's say this clock in is used here, and this clock in is used here. And for some reason I have directed this. This is the same thing as the clock in. This is also the clock in, controlling the random sequence generator. You see that is used at a lot of places, right? Okay. There are still some redundant components I haven't removed from this connection. Alright, this is our counter. You can see the label here, H1, H2, H3, H4. They are going to the hex displays. And you can see the connection is exactly what I've drawn in the sketches. H1, H2, H3, H4. From 0 to 9999. And this is the shift registers here. There are 16 in total, representing 16 columns. See, 16 from 0 to 15, you have all of these. And it is all directed to user input. I named the tunnel UI, and UI is here. UI is controlling these 3 panels of message. And the moving condition is here. Press 1 or press 2. Press 1 to move left, press 2 to move right. And this is the losing condition. it takes the condition from the user input and it compares with the loose condition. The loose condition here is actually the information from the 24th row, which is directed from here, the loose condition, right? It's taken from here, the very last row of the asteroids. And this is the smallest I can go. You can see there's a lot of this. I will explain how to connect this later. So you connect them with the AND gate, and lastly a 16 input gigantic OR gate, and then you connect it to the loose condition, and the loose condition is directed all the way here, loose condition. And you can see there is a clear score, so when loose is activated, it stores high here and is locked at high. Because this is not the clock, this is a set input. When the set input is 1, it gives the content 1, and clear screen is high. When clear screen is high, you can see that every single flip-flop here is restored to 0. So once you crash into the asteroids, your score will be reset to 0. Alright, what's left is this is some redundant components. I only use 1 and 2 now. P and R is from the earlier stages of designing this circuitry, and when I want P to be the pause button and R to be the reset button, but unfortunately that was before I implement the game over scene and it will not work now, so it's just there for some reason. I have yet to delete it. Redundant components bad, remove at all costs. Alright, and this is the random sequence generator. What it does is that you can see it have a seed. A seed is a original a primal information used in deciding where the random sequence will be. Because in a computer system, there's no true random. Everything is decided with logic gates. It's either logical 0 or logical 1. So you depend on a seed to simulate some degree of randomness, and this is actually very complicated. To put it in a simple term, if you use the same seed and you start at the same point, the 2 random sequence generator is going to give you the 2 same thing, because this random sequence generator is programmed to use some kind of algorithm in back. It can be some modulus algorithm, it can be addition, subtraction, division, multiplication, it can be exponentials, it can be logarithms, it can be a lot of things. And all of that is implemented to turn your seed into a particular output to simulate a certain degree of randomness. And this seed is whatever number you want it to be, whatever seed you want it to be. And we can see here initial seed, so this is clear. So if you clear, the pattern is going to repeat again. There is 2 ways to implement the asterisk falling. One, we can implement the asterisk falling from a preset pattern, but there will be no fun at all, is it? So I've decided to use this random sequence generator, and each time you play, you can change the seed to a different seed so that the pattern will be entirely different. And the bottom is, you can see that it tends to stick together. It tends to have a lot of ones stick together. So what I'm going to do is I use AND gates. Why do I choose AND gates before? Because I explained that AND gates have a 25% rate of going on, and I've used AND gates to connect them. Not in a particular pattern, I just think this is cool. You can connect them in your own ways. And this is Q1. Q1 is going here. No, this is Q1. Q1 is going nowhere because it's useless now. I forgot to remove it. Alright, it is gathered here once, and then it's gathered here again, and it's tunnel DD. And this tunnel DD is going here. It shows the information to be input. And you can see a quite effective implementation here. You can certainly make a better version of this. I just do some random operation on trying to do this. You can design your own gates too. The design is volatile. And you can see the output here is very good. The output is only a few lines activated. A few lines. Because you don't want all the asteroids to come together and block your entire path. So that's done a good job, the random circuit. Alright, so the only thing left is this gigantic shift registers. This is nothing crazy, nothing very complicated. It's actually very easy. So what you do is you think of each of these flip-flop represents a pixel. This represents the top left pixel in this matrix. And so it's connected here, and you can see they are combined with a splitter, and they are here connected to this panel. And you can see that is the 0th pin that this is connected to, so this line is actually representing the rightmost pixel. So if I remember correctly, 0 is here and 15 is here, left side. So it's actually horizontally inverted. So that's why my bad splitting happens. It's actually something wrong here. This splitter, it should be upside down. No problem, we just continue. The working principle is same. And you have this representing the second row of information, and the second row is taken directly from the first row, so you can see the connection from the Q output to the D input. If you are still confused on how does D flip-flop works, I recommend you to look it up. It's a very simple working flip-flop. But first you are going to start from latches, and then you are only going to see flip-flops. If you don't even know how a flip-flop works, I think you have just wasted the last 70-80 minutes of your life watching the video. Doesn't matter. Let's move on. And so you can see each splitter represents one row in the LED matrix, and it is only connected like this. It's very simple, it's just connections. So you want to keep a distance from one to another because you want to go all the way here. You don't want this flip-flop to end up blocking the path of these wires, or else it's going to be extremely messy. So all the way to the 24th row, and the 24th row is where the loose condition will be taken to be compared. So this is all the details on how do you make a game. So let's finally go to the thrilling part on how do you operate this. So, okay, first off, you are going to pick a location. You are going to pick a random location, and then you are going to start the simulation. It's currently in pause mode now, so I'm going to start the simulation. I'm going 32 Hz. Alright, so now the clock is enabled, and I press the pause. Here, and it goes to play, and it falls. The asteroids falls, and you press the keyboard. You press the keyboard to activate the input. Alright, you see the light blue circle here, and I press 1 and it moves, and it moves, and it moves. I press 1 and I press 2. You can see the numbers appearing. Oops, apparently I've crashed somewhere. Now let's move it here so that it doesn't crash with these alphabets. So you can see actually when you move, something actually is in the buffer for a little while, a short moment before the input is taken by the clock. You can set the color information here. These 3 panels I've set it to red. Oh, this is quite impossible. See, this is where some flaws are still there. My connection is not very good for this to be occurring at some places. My connection is not very good. You can make your own. You can design your own connections at the here, this one. So this is how you operate the game, and you can see the scoreboard up there. It started counting the first row it drops. So by the time it reaches us, is already at 24 points, but that doesn't matter. So you have a scoreboard, you have an input, you have a pause button. It pauses the system entirely. Even if your input here is not going to work. The one you just see is the fastest operation possible on the 32 Hz simulation. Is this yes. And then notice the scoreboard here. I'm going to crash into the asteroids. Bam, it's going to 0, and it's locked at 0. That is all on the details of how to make a asteroids game. And thank you very much. Hopefully you have fun watching this video, because it's very boring. So yeah, thank you again for making it here.